So I decided to change it up a little bit. I'm outside now. I've been working on this video involving the Goldilocks Zone for like probably a week. It doesn't feel like a video that would be a long form. So I figured it just stormed. It's kind of nice out. It's a little humid. Um, the table is that I'm on is quite wet. It's a different setting than being inside the house. So I figured I'd try this. I'm trying to relax a little bit with this video instead of writing out a whole script, which I do have a little bit. Just made my coffee. I woke up like 30 minutes ago. So let's see what happens. So day to day, we obviously live with a lot of misconceptions. Like my introductory physics class, we had a recitation with one of the professors at the college, and he would talk about new people that are learning something like Newtonian mechanics don't necessarily understand the intricacies of it, which is fine, obviously. It's important to understand the limitations of what you understand. All of us know things a little bit better than other people, and different things that we're good at. Like when you're explaining something new to someone, there's a lot of subtlety in what you're saying. Something like this pops up in physics classes, all the time. It's important to understand where your understanding fails. And that's kind of what led me to make this video about like the Goldilocks Zone, which, if you're unfamiliar, the Goldilocks Zone is just some boundary around some star, any star, that liquid water can persist on the planets within that boundary. You've probably heard of it, especially if you've been recommended this video. The rest of your feed is probably already space or astrobiology related content anyways. What you might not know if you're not a scientist in the field, or maybe you didn't put two and two together, is that the Goldilocks Zone idea is kind of a sham. And I don't think it's like a malicious conspiracy kind of sham. I think it's more of along the lines of scientists needed a way to communicate finding life, and something like just liquid water persisting is what for most people would be like, okay, if liquid water can exist there, there's probably liquid water there, and there's probably life there. So if it's in the Goldilocks Zone, there's life there, we're good. But that's not how it works. So some common misconceptions, of course. If we're in the Goldilocks Zone, there's life. Nope. So in our solar system, we have 3 planets within the Goldilocks Zone of our star. Every star system has its own Goldilocks Zone dependent upon the energy output of the host star within that system. And then if you have binaries, it gets really, really complicated. There's bugs out here. But something like our solar system, so we have Venus, of course. Venus has a runaway greenhouse effect, in which the feedback mechanisms on that planet, it doesn't have the ability to remove the carbon dioxide from its atmosphere. You get something like incredibly high temperatures at the surface that make it very difficult for any type of chemical reactions to take place, for life to thrive. Anything that is on the planet is going to be scorched. It's incredibly hot at the surface because of this runaway greenhouse effect. And on Mars, you have a very limited atmosphere. There's nothing to keep the heat inside the atmosphere. And another thing, you don't have something like advanced plate tectonics on Venus or Mars that we have on Earth, which on Earth we have the carbonate silicate cycle, which essentially just helps take carbon dioxide out of the atmosphere and recycles it. And it's a huge cycle. It involves the oceans, obviously the atmosphere, volcanoes, bacteria, everything. Oh god, it's raining. I had this fear that it would start raining in the middle of this video, so I think I gotta go inside. Alright, we are now inside. So what I was getting at when we were outside is that even though our solar system has 3 planets within the Goldilocks Zone, only one of them so far that we know of harbors life. There were detected biosignatures, potentially detected biosignatures in the upper atmosphere of Venus. Since that paper like 5 or 6 years ago, scientists aren't too sure if that detection is correct. Obviously, more work needs to be done. A lot of scientists still think that there is potentially life under the surface of Mars, maybe in areas where water persists under the surface. or maybe even at the ice caps, but we're not sure yet. And even if there is currently life, it has a hard time persisting over the entire planet that it lives in. But of course, we have Earth, which is the only example of life that we know. Even if you're within the habitable zone, where if you have water on your planet, which is implied by the definition of habitability, if you're too close to your host star, you're more than likely going to be tidally locked. And if you're tidally locked, that messes with the potential energy distribution on your planet. Something like Proxima Centauri B is tidally locked, as we think currently. And the problem with tidally locked worlds is that the energy or the thermal gradient on the surface is insane. So you have one side that's very hot and one side that's very cold. And so there's some theories that life can exist in the twilight zone, which is the region between the hot and the cold side. And the thermodynamics of it, or even just the fluid mechanics of it, are very interesting. The idea is that there's these like convection cells that are created on the hot and the cold side. These convection cells essentially allow it so that the twilight zone could potentially harbor life. And likewise with something being too close to the host star, if I think with Proxima Centauri system, if you're too close, then stellar winds can strip your atmosphere. Even if you're within the habitable zone, it is still a very uninhabitable environment, at least for life as we know. If you're tidally locked, you can't develop your own magnetic field as easily, which makes it hard for biological life to persist as well. And something like Venus experiences this effect where there's very little magnetic field, and same with Mars. But Mars is a bit different. It's for different reasons, not necessarily. It's not tidally locked, of course, so the reasons are a bit different. But then you have worlds that we're exploring, that we're going to explore soon, that aren't within the habitable zone. And these aren't even planets, they're moons. You have something like Jupiter's Europa, which is a very good candidate for having oceans of liquid water underneath its surface. We have ideas such as like tidal flexing from Jupiter's gravitational pull that is causing movement within Europa itself, which obviously movement is very important for energy, and energy is very important for life to utilize, for chemical reactions to occur, to catalyze these chemical reactions. I know I'm being very general about these things. Even just moons are enough to potentially harbor life, and even if they're not within the habitable zone. And then you have something like Enceladus and Titan, the moons around Saturn, which also experience varying effects that in theory can provide enough energy, hopefully, that would allow life to develop on these worlds. And you know, the idea of the Goldilocks Zone isn't bad. It's very useful for scientists to be able to get time on telescopes that are on the ground and in orbit. If you say that the planet that you're observing or the solar system that you're observing has planets within its habitable zone. So in that way, it's useful being like, yeah, we're looking for life, and there's potentially life on these worlds because they're within the habitable zone. But now, as we know, that this idea isn't necessarily correct. I think that it will lead to, in my personal opinion now, this is an opinion because we only have one evidence of life on one world right now, but I feel like you are more likely to find life on something like some of the moons, like Europa or Enceladus, than you are on the worlds within these habitable zones. If you like this kind of thing, let me know. If you don't, I can go back to more longer forms where I do significantly more research and go more in depth into the modern research on something like the idea of our current understanding of modern habitability. This is kind of just a short, just me thinking sort of video, just my thoughts on it. So I hope I gave you something to think about. See you next time.